Welcome to and today is our second session. So in the first session, you learned how to containerize and deploy a simple website. And in this session, you'll be simplifying that with the help of operators. And in this workshop, we'll be exploring operators to simplify app deployment. We also have two more further sessions, which will be following up on 13th of July and 15th of July. And the 13th of July session is going to talk about continuous integration, and 15th of July is going to talk about deep learning models into a services application. So for today's session, we'll be exploring applications using operators. My name is Fawaz Siddiqui, and with me I have Masa Abu Shamle. We both are developer advocates at IBM UAE, and we are so happy to be here today and to present to you. So before we start, some housekeeping. You can all view more about this event on the top left of the window. You can click on the eye icon and get the links, and the next sessions as well are available at the more section. I'll dive deeper into that. On the top right, you can follow IBM Developer and get notified about all the other events which are coming forward. If you would like to chat with anyone or follow instructions, we'll be posting them in the chat. You can chat right here on your bottom right. In case you have any question, we have an Ask Question panel, which will allow you to ask any question which you have, and we'll be answering it right there. We have posted some polls already, so you can interact with those to help us get a deeper understanding towards what your understanding is, and we can tailor the content according to that. Lastly, you can access the workshop resources in the green button right below the screen. So how do you get to the other workshops as well? So on the top right, you should see schedule session 1 of 4, and you can just click on the more part, and you will see the 4 workshops which are required for this section. And you can basically go to the other workshops which are going to happen on the next dates. Let us know how you're doing throughout the workshop. You can scan this QR code or go to ibm.biz/bsok-survey, which will allow us to know how we are doing during this workshop and if you have any questions. So let's get started for today. Before we start, we do have some prereqs. So make sure you have logged in and signed up for IBM Cloud, and please use this link, which is ibm.biz/bsok-series. All the tutorials and the quiz, which will allow you to gain a badge, it's at ibm.biz/bsok-skills. Do let us know how you're doing, like I mentioned in the previous slide, at ibm.biz/bsok-survey. And finally, to get your OpenShift cluster, which will be required for the lab, by the way, go to the link, which is bsokbootcamp.mybluemix.net. You will enter your IBM Cloud ID and the key, and my colleague will be also posting these instructions in the chat, and you can get those right away. So let's talk about today's content. So we'll be giving a minor introduction to Red Hat OpenShift, and then we're going to talk about operators, the operator framework, OperatorHub, and then Masa will do a code lab with all of you, and then we're going to talk about some useful resources. So IBM and Red Hat, they are the leaders in hybrid cloud right now, and this obviously talks about deploying applications and various components in the hybrid cloud world. So what is Red Hat OpenShift? So Red Hat OpenShift is basically a platform for deploying cloud-native microservices-based applications. It can be hosted locally, on-prem, or on a public cloud server. And finally, it's built on top of Kubernetes, and it's basically deploying application based on Red Hat Enterprise Linux Core OS and RHEL, which is Red Hat Enterprise Linux itself. So it allows you to deploy all your applications and manage them all together, making sure that since it's a microservice-based application, all the microservices need to communicate with each other. And basically Red Hat OpenShift, which again is built on top of Kubernetes, helps you do that. So what does Red Hat OpenShift enable us to do? First of all, it's all about simplified cluster management. So your clusters are managed simply in a very simplified manner. You have a developer portal and an administrator portal, and you can check what pods are running and how the applications are interacting with each other. Further ahead, you can also design your own cluster. There are a lot of flavors for the cluster. Basically, you can expand the RAM, you can expand the worker nodes, and that doesn't really mess up your workloads, which are already running. So it's very scalable at the same time, and you can also design it according to what your requirement is. There's security and isolation. So all the projects are, there's isolation between each and every component with the help of projects. This makes sure that no other components are interacting with each other unless you obviously want them to. You can further extend apps with the IBM Cloud Services. So you can 100% deploy some IBM Cloud Services on Red Hat OpenShift as well. Red Hat OpenShift is completely native open source experience and a native open source experience, basically. It's all open source. The source code is available, and Red Hat is one of the biggest open source contributors in the market right now. And finally, integrated operational tools. So this includes monitoring, logging, and OpenShift really does have some interesting logging methods, which really tells you about how your application is doing in the cluster. Excuse me. So let's talk about operators. So what are operators? Basically, it's a method of packaging, deploying, and managing a Kubernetes application. So it's more of a pieces of software that ease the operational complexity of running another piece of software. So these could be operators, could be databases, installation kits. This could even be something. The most famous operator, which is there on OpenShift, is Knative. Okay, so these applications or mini packages can be actually installed all over the server or on the namespace itself or the project, which allows you to really ease up the application deployment over as an overall. So why would you actually use operators? First of all, it's their repeatability of installation and upgrade. So as and when you upgrade, it happens automatically. There's constant health checks. There's over-the-air updates for OpenShift components and ISV content, and it also encapsulates knowledge from free experience and spreads it to all the users of the cluster. So, for example, let's say that once a user here modifies a custom resource, it changes the events and then it adjusts the state in the Kubernetes API, and then the operator starts watching those. And throughout this cycle, the operator is actually watching the custom resource, ensuring that it is doing its job and making sure that the state is adjusted accordingly. So how do they actually work? First of all, they really extend the functionality of Kubernetes, and it sympathizes human knowledge as code. They're scalable and repeatable application management technique. They're very much useful in the hybrid cloud environments and also reduce a lot of complexity. So let's say, for example, that there's somebody pushes a container image, or let's say the OCP update service works. Okay, the cluster version operator actually checks for updates, and then it accordingly updates through Quay.io, which is Red Hat's own repository for container images, and then it downloads the release image for the update. So it's done in a cyclic method. Okay, and it's as and when you update your source code, it continues to update that over the air and at real time. So operator framework, we're going to talk about several factors here. First of all, the Operator SDK. Basically, it allows you to author and bootstrap operators itself. So many there you can build custom operators on OpenShift, which allow you to really do what you like, and that really depends on your use case. If you're working for a particular use case, if you're working on a particular use case, you can build it using a custom operator using the SDK. Then the operator lifecycle manager basically controls the installation, upgrade, and role-based access control of operators on the OpenShift cluster. The operator registry stores the cluster service versions, CVSs, and the custom resource definitions for creation in the cluster, stores operator metadata about packages and channels. And basically, it also runs Kubernetes or OpenShift cluster to provide operator catalog to the OLM. OperatorHub, basically, it's a web console which administrators can use to deploy the operator on the OpenShift container platform. And operator metering, basically, it speaks for its name itself. It's more about monitoring those operators and making sure that they're working at their optimum levels and making sure that everything is working fine. It's a part of logging, like I mentioned in the previous slide, and it's something very much useful. So how does it look like? Let's say that there is a cluster admin and there's an operator developer and then there's a user. So the operator developer develops operator, which could be based on Helm, Ansible, and Golang, right? They create, they package operators, and then the operator installation is done by the cluster admin. So this involves dependency resolution, the CRD lifecycle, and any collision detection which the operator might have. So making sure that it doesn't collide with the existing components on the cluster. More right after that, the admin conducts operator updates, and the user is able to discover those operators and have rich UI controls. So it's a cycle. It goes from end to end, from left to right, making sure that the developer develops the operator, admin installs, and the user can finally use it. So this obviously means the RBAC, which I was mentioning in the previous slide, role-based access control. So every role has a particular thing to do here. The developer develops, administrator installs, and the user uses it. So OperatorHub, it's basically the web console which is used by administrators to install operators. It's only available as a web console, and there are 4 types of operators which are available. First of all, there are Red Hat operators, there are certified operators, there are community operators, and there are custom operators. So Red Hat operators are operators which are namely provided by Red Hat, right? Certified operators are certified by Red Hat to be on the Red Hat on OperatorHub. Community operators are operators which are actually developed by the open source community, and this could be for databases. Like one of the most used operators which I use personally is the Postgre operator. And finally, there are custom operators which your developers are making for your clusters. This really is based on the use case which you're working on and how you're working on it. So Operator SDK, basically this is what's used to make an operator for a custom operator, or by anyone who's making who's an operator developer. So it gives high-level APIs and abstractions to write the operational logic more intuitively. It's basically a scaffolding and code generation tool to bootstrap it to a new project. And extension covers common operator use cases as well. So it does have an extension-based thing where you can cover up very common use cases. So the Operator SDK, basically, the developer uses the Operator SDK to create a new operator right here. It provides scaffolding and a custom logic, which then is equal to a Kubernetes operator. And this could be implemented as a container image as well, based on deployment, role, cluster role binding, service account, or custom resource definition itself. And when we're talking about the Operator SDK workflow, excuse me. So when you're talking about the Operator SDK workflow, basically it's more about build, test, iterate. So you build your foundation. In the foundation, you start building it, you build your operator, and then you start testing locally. So local testing and the testing with the live cluster, it's completely different, because local, when you're on a local environment, you have a different environment variables. When you're on a test test environment on a live cluster, there are different environment variables. So you need to ensure that this is a very long process. By the way, it does take some time, because you need to ensure that your operators are at the perfect level. And the rest, the next part is to basically publish the operator. You're going to create, once you publish the operator, it could be an operator manifest and an image, which can allow you to post the operator and go ahead with using those operator on your cluster. So operator maturity model. Okay, so this is how an operator matures. Now, not every operator has to go through all of these phases. Some of them just go towards a full life cycle phase. Some of them go to the full cycle. Depends on the complexity and the usage of the operator. So basically, the first phase is the basic install. It's done by Helm, right? It's an automated application provisioning configuration management. Then you come to phase 2, where you do seamless upgrades, basically patch and minor version upgrades based on the bugs which you notice and all of these things. And then we come to the third phase, which is the full life cycle of an operator. You have application life cycle, you have storage life cycle. So there's backup, failure, and recovery, which is covered in this phase. And the fourth phase is deep insight. This is where you actually start getting metrics, alerts, log processing, and workload analysis based on what your operator is doing. And finally, autopilot. And this is completely autopilot, where the name says it, right? There's horizontal and vertical scaling, auto config tuning, abnormality detection, and also scheduling tuning. So it really depends that, hey, maybe at this time I'm going to face a lot of traffic. So it starts scaling scaling accordingly. So throughout these phases, there are 3 technologies which are very much involved. There's Helm, there's Ansible, and then there's Golang as well. So finally, we come to the code lab section, and Masa will be doing the code lab. So before she comes here, really appreciate it if you can log in or sign up into IBM Cloud using this link. The hands-on guide is at ibm.biz/explore operators. And you can get your OpenShift cluster at bsokbootcamp.bluemix.net. Masa, over to you.
Okay. Thank you, Fawaz. I will share my screen now. Thank you, everyone, for joining us. Okay, so I will do a little bit of guidance before I jump right into the hands-on. Hopefully, we will clear some things that might not be still, clear for some of us here. So we do have several links that we have shared with you in the chat. So one of the links, which is the link to the entire resources for the bootcamp, in which you can find all of the workshops for each workshop we're going to have for 4 labs. Okay. Right. So next thing is so you will have access to these labs at any time. You can read them. You can at your own pace. We have the clusters available for you for around 24 hours after the workshop. So make sure that you have your IBM ID is the same one that you are going to use when you are logging into the skills network. Which is this page, similar to the one that you are using to register to IBM Cloud, because at the end we will be, as you can see here, if you scroll all the way down, you will see that there is a test your knowledge. This will be enabled towards the end of the bootcamp, which is next week. So you can attempt the quiz once we finish presenting the third and the fourth workshops. So you will have, at each workshop, you will have clusters available for around 24 hours. Feel free to attempt them all at once when you have the clusters. So you will have this link here. You will be able to just enter OS Lab and add your email. Once that's done, you will receive an email from IBM Cloud that says you are invited to join an IBM Cloud account. So make sure to accept it, and you will be redirected. You can access it from IBM Cloud right away. So the IBM Cloud account that we will be added to is called AdvoWork. And for example, I have multiple accounts here. Some of them are mine. Usually, you will have like AdvoWork and, for example, IBM or your name to add it to it. It really depends on whichever account you're added to. Today we will actually be using two accounts: your personal accounts and the AdvoWork account. The AdvoWork account is for the clusters, and the personal account is because we will be using one of the services at IBM Cloud. So next thing is, so normally you will be in the resource, in like the main page on cloud.ibm.com. You're going to need to access your cluster, and that is done through the resource list. So you will have a dashboard here. Sorry if it's a bit slow, but to the left, top left, you can select on the hamburger menu and then select resource list. The resource list will show you all of the services that you can access on IBM Cloud. So yeah, it's a bit slow on my side, but once that's done, you can view the resource list, and this is where you can find your cluster that is assigned to you. So keep in mind that so each one try to have like one cluster that you can use, so everyone can have access to it, and it's also on a first come first serve basis. So hopefully everyone who is following along with us will be able to have each one a cluster. So I'll be using this cluster. So your clusters will be in the format BSOK Bootcamp, and then a random number based on the order of it. Okay. So once you click on it, you will be, directed into the dashboard of OpenShift Web Console. OpenShift on IBM Cloud. You will see all of the details of your cluster here. So we're going to go to select on the OpenShift Web Console button, so we can access it. We will be working mainly today with the Web Console, which is the GUI of OpenShift. You can actually work on both the Web Console and the CLI when you're working with OpenShift. Now, first thing you're going to notice is that we do have two perspectives, maybe if that's what you're going to notice, which are the administrator perspective and the developer perspective. Each perspective has its own, I would say, functionalities. So as an administrator, it's like the ultimate user to the cluster. They can do anything on the clusters as admins. They can manage the operators, the users, the storage, the projects, workloads, and much more. So, and as administrators, today we will be working with operators. And then there is the developer perspective, which we will also be using. And this is mainly the role of, as developers, we would be building and deploying our applications. So the actually tutorial for today's lab is going to be lab 2, which is Introduction to Operators on Red Hat OpenShift. And it has several exercises. If you click on Start Lab 2, you will be directed to this GitHub repository that has all of the steps that you can follow along. So what we will be building today. So first thing is, this is the UI of the application. It's an example health application that shows us the records and data of the patients in the database. And once the user logs in, this is the review. So they get a history of their appointments and their medications and some location and personal information about them. So if you first build this application, you will eventually see some dummy data. So it's not going to be connected to a backend. And this is where we will be building a kind of like a 3-tier architecture application. So this can be explained here in the architecture diagram, as you can see. So it's kind of a small version of a microservices application where we have the front end in a Node.js application that we as users can interact with. This front end application is connected to the back end, kind of like API calls, I would say, like, because we will be later on, we'll demonstrate how we can connect them together. And this back end application is connected to the database. And we're using the operator to kind of like create the CloudDB, which is the database that we will be using. So it's like a connection between the back end and the database itself. So on the first day, you learned how to deploy a simple application using Golang, and it was using a Docker file. Today we'll be kind of doing the same, but we're going to learn more things. So, one of the ways that you can build and deploy applications is source to image, and this is exactly what we will be doing today. So we're going to take a look at that as well. So first thing is so the steps are clear here, actually, hopefully. And simply we're going to create and deploy the Node.js application for the front end. So how we can do that? You can do it in 2 ways, but I will demonstrate at first the through the web console, which is really easy. It doesn't require you any commands to type down. So from the developer perspective, just make sure to select here at the top next to the menu, all projects, for example, and then select to create project. You can give it a name, for example, example health project. You can add a display name and a description and hit to create once that's done. So once you create your project, it's empty. You still don't have any applications, and this is going to be the view of your topology. So as you can see, we have so many options of creating applications. We're going to select from Git because we will be importing the code from GitHub. You can find the link to GitHub from the tutorial itself. So if you scroll down, you will find in step number 7 in the exercise the link to the GitHub repository, which is github.com/IBM/IBM DTE samples. So just copy that and go back to the OpenShift web console and just paste the URL. Next thing is this GitHub repository. It actually has 2 applications, the front end and the back end, and they are each in their own directories. And so we have to specify the context directory, which is here. So the context directory will be the name of the folder where our code resides. So it can be found, the name of this directory can be found in step 10, and it will be Red Hat OpenShift on IBM Cloud /node s2i OpenShift master. So go back to the OpenShift web console and paste the context directory. So right now it has detected the builder image, which is the Node.js. And you can also notice that there are different versions. So it depends on what kind of image version you want. We can actually go with the latest one. Next thing is specifying the application name and the name of the name itself, like unique name. So they are a bit different based on the first one, which is given to the application grouping to label the resources, while the second name is so that the name is used to associated resources. So they are a bit different. Usually we name them the same to clear any confusion, but in this example, they're named differently for a bit. So the first one is going to be the application name, I believe. Yeah, the application name is going to be Patient UI, and the name will be Node S2I OpenShift. So hopefully this is clear so far. Okay, so far it's been very simple. We have added all of the details of the application through this UI here. We really were not required to do any coding, aside from having the code in the GitHub repository if you are following a real-life use case. So we're going to keep the resources and the route as is, because we need a route for it. And we're going to create it as a deployment, not a deployment config. And then hit to create. It will take around a few minutes for it till it's running the application. So the cool thing is that it has this really nice UI that you can see the details of it. So this is the pod of the application that we are building. So this won't take long, and if you click on Open URL, you will notice that the application is not available. Once the application is running, once it becomes dark blue, it will change and show us the UI. Till that is, going to, build, let's take a look at the next steps. So you can scroll down all the way in the GitHub repository and go to exercise 2, in which we're going to learn how to install the operator from OperatorHub. So this is where we're going to really start with, focusing on operators and using them in our application. So let's see about operators. Okay, so let's go back to OpenShift Web Console. So as you can see, it's making changes here. It's a little bit. It's currently container creating. Okay, I will leave it for a bit for now. And then let's go back to administrator. So as administrators, as Fawaz mentioned earlier, only administrators are the one who can manage, the operators. And actually, you can only work with operators from the web console. You cannot install operators from the command line. So we can go to operators from the main menu and go to OperatorHub. OperatorHub is where you can see all of the types of operators, whether it was Red Hat OpenShift operators, or if it was certified or community operators. These operators, they vary between machine learning, big data, databases, and so on. Actually, let me check really quick. Yeah, there you go. The application is now running. So I just refreshed it. And yeah, also just make sure that, the way it is written, like it already starts with the /forward in that section. So don't add it yourself. So going back to OperatorHub, you can install directly the operators from there for free. There is something also called Red Hat Marketplace, in which you would be, buying some operators or, using free trial. These are enterprise usually, but you can also work with OperatorHub, to just install them directly without using a Red Hat Marketplace. So today's operator that we're going to use is called IBM Cloud Operator. So you can use it from the filter. And it is a cloud provider operator. So it is provided by IBM. And speaking of a cloud, you can actually use other operators provided by other cloud vendors as well. Now, the one that we will be using is called IBM Cloud Operator. So as you can see, there are different ones. To me, in my screen, it shows the one to the top right of the list of the operators. So if you click on it, so you'll be shown this kind of pop-up here. Just continue, because it's just showing a warning because it's a community operator, but we can still use it. And the list here shows you some details about, as you can see, about the operator itself. Now, what does this operator do? This IBM Cloud Operator, it has two features, which are the service provisioning and the bindings management. What do? Simply, they create a service for you on IBM Cloud. So make sure to install it by clicking this button here, and you will be redirected to install operator page. So there are different updated channels, but it's better to go with a stable. The L5, I believe it's for testing. And then there's the installation mode. You can install it either on all namespaces or on a specific namespace on the cluster. But if you install it on all namespaces, you really don't have to install it every time you are creating a project. So you can just, use it on any project that you want. In the future, if you want to use any other service on IBM Cloud, you can just do it directly. So click install. This will take a few minutes, not so long. So till that happens, so it's going to be then installed in installed operators. So you will see it there. So currently it's showing just no operators found, but we'll have to just give it a few minutes. In case if you don't see it, you will have to refresh after a few minutes. So till that is going to get installed, yeah, there you go. So it's now showing us that it's being installed, or it's already installed. Yeah, it's currently in the status of installing. And we can click on it. Now it has finished. So that's great. It didn't really take much long to install. Okay. So if you go to IBM Cloud Operator, you will see some of the details. Some of the details of this operator, like what kind of APIs it provides, and they are the binding and the service. But we will not be using them for right now. Why? Because we're going to need to connect our OpenShift cluster with IBM Cloud account. Now, in this step, make sure that you are connecting your own your own IBM Cloud account. So first thing is, let's take a look at the documentation. You can find also the steps here. And highly recommend that you would have the documentation open, because we will be using some of the code in it in the next steps. So as you can see here, so far we have installed the operator. Next thing is we're going to need to log into IBM Cloud. So go back to IBM Cloud itself, the cloud.ibm.com, and select on the accounts. So go to your personal account, which is like shown just like IBM or your name. So now that it is loading, I need to check real quick if I have a service created. So what do you need to do is you're going to need to log in through the command line. This is where we're going to need the shell. So I'm going to share a link with you. I think it's, I would recommend using it, because in case if you do not have OpenShift command line or IBM Cloud command line on your local machines, you can use these commands, on the cloud. So let's see, I'm going to actually switch the accounts for now. I will be doing some slight changes to my own, but you can just copy it. No, actually, it's better to go with my own. I'm sorry for the confusion. Maybe I'm giving you guys some time to follow along in case if someone is still not following along. So I just need to make sure, because I think I have deleted, I have used a cloud service and I forgot to delete it, but I need to demonstrate how I'm going to use it. Okay. So I think I have a cloud service here. So first thing is what you have to do while I try to find the service to delete it. Go to your to the top right here on your IBM Cloud account and click on login to CLI and API, and then copy the login command here. So login IBM Cloud login, and then go to the shell and paste it. And then select the region. I'm going with like Europe, Great Britain, because it's the closest to my region. I might actually have to go with the other account. But yeah, go with your own accounts. It's just because I will have to use not the light service, but you will still be able to use the light service. Okay. This one will be much easier for me. Okay, so I'm logging into the new one using the same command. And then next thing is we're going to have to target the resource group that we will be creating the service, which is a cloudant. So you can also find the command here, IBM Cloud Target --CF-G default. This one is, so in your, sometimes in most cloud accounts, the new accounts, you will have either default with the small letter D or capital letter D. So if this gives you an error, just to change from small d to capital D. So I'm going to try this one. Yeah, so I have a resource group called default, which is great. And then it's going to show you the details of your, of your account here and there. So like which resource group I'm using. So that's where I will be creating the service. So let's see, the next step is we're going to need to log in to our OpenShift cluster from the command line. And so go back to your OpenShift cluster, and you can just go to the top right, click on your name, and copy login command. So this is how you usually log into OpenShift by copying the token, which starts with the OC login. So display token, and copy the token. Go back to your command, your Cloud Shell, and just paste the command. And it will show you that you have logged into the cluster, and you are now using the project default. At this step, we will be using project default. So in case if you are using a different project, just make sure to use OC project default, because this is where we will be now adding our credentials of, this is where we'll be connecting both the cluster and IBM Cloud accounts. So let's see, you will find a curl command. So if you are working, on your local machine, You can, on Mac and on Linux, you can use curl. On Windows, you can use git bash to run the curl command. So copy this command, and this command is just a ready command for you that is like a helper script, and it will create for you config map and a secret that you can use for, for your applications to be able to use IBM Cloud through OpenShift. So once this command is done, it will show you that secret is created, config map is created, and the last command here. So let's see, next step is, so if you want to also verify that everything has been set, you can use the OC get config map command. So this command is basically showing us the details of the config map we just created in a YAML format. So the -o YAML format is showing us, how it's going to look like in the YAML definition. And the last thing is where -n shows us -n, then the name of the project where this config map resides. So copy this command here and go back to your shell. So as you can see here, let's take a look at it. So it's showing us that usually in OpenShift you will see that the way the YAML definitions are, if you are familiar with them or if you are learning them, they're kind of in the same format where you specify the API version and any kind of details related to the resources that you are working with. And in our case, it's showing us details of the config map related to the IBM Cloud account we just connected the cluster to. So these kind of act like environment variables, when you're working with the operator. So as you can see here, I just specified, for example, the region that I just selected, the resource group, and then the username, which is my email, and any related data that is related to it. If you go back, there is a second command similar to get config map, but this one is OC get secret, so it shows you the details of your secret. So just paste the command again, and you will see also similar details, but this time it's a secret, and it's showing, for example, the API version, and then you have the API key and the region and the kind of the secret. Now this secret, there are so many types of secrets on Red Hat OpenShift, like TLS and opaque, if I'm pronouncing it correctly, but opaque is usually the default secret. Whenever you just want to create a secret, like a generic secret, it will be of type opaque. So this will now, when we connected our IBM Cloud account with the OpenShift cluster, we will be able to use and create our services through the cluster. So that leaves us to the next step, which is to use the operator. Now that we have set everything up to be able to create, to be able to use the operator, because this is how you would be working with this operator, and it can differ from operator to another one. Now this operator kind of simplifies how we are creating the services on IBM Cloud and using them directly on the OpenShift cluster. So the next thing is we're going to create the cloud and service, okay? So you can, when you go to the documentation in exercise 3, you will see this code here, which is like in a YAML format, and it's of kind service because we will be creating a service, and then the metadata. So the name of it, which you can change however you want, but you have to make sure that you are using the same name when you're going to connect the credentials with the name. And then you specify the plan and the service class. So the service class is the type of service that you are creating, and in our case, it's a cloudant. And the plan can be either light or standard or premium. It depends on what kind of a plan you are using. So just copy it, and let's go back to the OpenShift cluster right here. Make sure that you are on the example health project, because we want to create the service and the service binding in the OpenShift project. I mean the example health project. So in the details tab, go to and select the service create instance here. And you will be directed to this view, which is like a form view, but we want to work with the YAML view. It's much faster. You might be more comfortable with the YAML view if you are more comfortable with writing code on your own. If you are not familiar with writing code, you can just use the form view. But it's much faster to go with the YAML view. Just a second. So just remove the text that is there. This is just a default text, so just delete it. And paste your details here. So I'm going to just make a few changes. So I'm going to add a few things here. You don't have to make changes. This is just me making sure that I do not create a replicated service, for example. And the plan, I will make it a standard, but you have to keep it light, like because with the free accounts you can only use light, but I will have to go with the standard. So you don't have to make any changes to your YAML definition. So as you can see here, it will show you the status that it is in pending. It will take a few minutes till it's created, and once it's now currently it's in the progress. Now it's a provisioning, so that means it's going well. Once that's done, it will show us that it is in a state online. So we can view the service from here. If I paste the name of the service, it's probably not going to show yet till it's online, actually. So yeah, this is the service. It's either online or it's going to show me that it is being provisioned. So I'm going to access it for now. Okay, so I'm just trying to open it. Maybe my internet is acting slow today, but yeah, let's see. So if we go back, I'll try to refresh it. So sometimes you might have to refresh, but usually they are updated like without having to refresh, actually. Okay. So it's still in state provisioning. It might, yeah, provisioning services can take a few minutes, so that's totally fine. It depends on the service itself. So I'm trying to find it here. Yeah, there you go. So it's currently showing me that it's active. So if I click on it, it might show me online. So before creating the binding, you have to make sure that your service is in online state or is already created. So it shows to me that it is created. So I'll try to actually create a binding. Yeah, so there you go. Because it's like kind of a using API, so it might take a little bit longer to update, but that's totally fine. So now that it's showing that it's in a state online, we can go ahead and create the binding. So when it shows online, it has been created successfully. In case if it shows any errors, that means you probably either using the wrong type of plan, or maybe you already have a service already have a different name, the same name of your service. So you have to be careful as well with the naming. So next thing is go to create binding. So when you go to the binding tab, you can also show it from the details tab and then create instance. But we are at the binding tab. We can just click create binding and go to the repository again and scroll down all the way. So this is showing you the details of the service itself. Now, if you go to step 8, you will find the code for the binding. The binding is that will create for us the credentials. So let's go back to OpenShift, and it has a similar view to the service. So we're going to just go to the YAML view. And similarly, we don't really need this code, just delete it and paste the code that you just took from the GitHub repository. Now, in my case, I will have to change the naming of the service. Here, you don't have to change it. Only myself will have to change it. So just make sure if you change the name of your service, that you're going to also change it here. So what this code does, it's specifying the API version. The kind is a binding, and the name of this binding is a Cloudent binding. And then the service name is whatever I specified. So this binding is associated with the name of the service that you have created, whether it was a Cloudent service or Watson service, and so on. So it doesn't matter. It just what type of service it is. The service name is what matters the most. So hit the create, and it will create it for you right away. It won't take long because it's the credentials. And if you go back to your service, you will be able to view the service credentials here. So let's try to. I try to refresh it. So it's currently in state online, so we can use it. Okay, so if you click on the Cloudent binding, you will be able to see the details of it. If you go to resources, let's see. So yeah, this is the Cloudent binding here in IBM Cloud. So we have created it through OpenShift. So we will be able to use it for our applications on Red Hat OpenShift. So if you go back to it, let's see, we can view the secrets. We were led to a different place, which is the secret, because it is a secret that we were creating just now. So go to binding. I think it's going to be somewhere. Let's take a look where it's going to be. In resources, yeah, on Cloudent binding, which is the secret that we created. Okay. So yeah, so the binding that we just created a secret for us to be used as environment variable. So we can, we're going to use it in the application that we will be creating in the next step. So going back to the repository, we are done with the step 3, and we're almost done with the entire workshop. Almost done, not yet though. So in this step, we're going to create the back-end application. So if you remember, I explained that we have 2 applications, a front-end application that is connected to the back-end application, and the back-end application is connected to the database. And this is what we will be building. Now, first thing is we're going to use, so this is a different way of deploying applications on OpenShift using the command line. earlier I showed you how we can create the application on the web console. Now I'm showing to you how we can create it on the command line. So go back to your Cloud Shell, but make sure that you are in the example health project. So select OC project, example health. And next thing is we're going to use the OC new app command. So let's take a look at it. So the OC new app, we're specifying the name of the application, and then the image. This is the image of the application. So you can specify the image if you want. And you can actually just use the GitHub repository, and then it will be automatically, detected for you. So in case if you don't want to add it. Next thing is the context directory. So as I mentioned earlier, we have one GitHub repository for both front-end and back-end applications. So we have to specify the context directory for each application where their codes reside. So I'm just going to create the application. And as you can see, it's currently building the image for us, and it is done. And if you go back to your OpenShift web console, move it from the administrator perspective to the developer perspective. So you will see that you have two applications. But you will notice that actually patient DB is going to fail. And that is because it's going to need to use an environment variable. So it's currently running. The build is currently running for us, but eventually it will fail and it will show us a red circle around the pod. And that is because of the issue that we are going to face in the next step. So as I mentioned, we are connecting the Cloud service to the backend application. And actually, we didn't do that yet. So we have to do it. So you will see that's currently in container creating. It might show it to you that it's, things might seem fine at first, but we still did not get to the step where it's going to fail yet. I just want to show you guys how it's going to fail. So let's see. And we can actually view errors of it. And it's going to tell us I think something around environment variables. So it's currently running, but it's crash loop back off. Oh no. So let's see view logs. I want to show you the logs actually. Let's see what's going to tell us. So it's telling us, okay, the logs are streaming. They're taking long, I think. I mean, they shouldn't because we just saw the logs. Let's go to events. So it's restarting the failed container. I actually don't want that. But yeah, one of the things with OpenShift that's going to keep on restarting the container, and it's going to eventually stop it if it keeps on so like your container fails, OpenShift will restart it for you. It fails again, it will restart it for you. So this is something like, having it to try to, just run it. Maybe it will work in the next time. But eventually it will just stop because then it will realize that it's not, I would say, it's not working properly, and we have to take a look at it. So it's kind of a way to try to make sure that, that the application is running properly or not. So it's currently, you can notice that the error here is we cannot find Cloudant credentials, Cloudant URL. So this is one of the errors that we have. So how we can fix it? This is very simple. So when you have credentials that you need to use, just go to environment, because this is where we will be using the environment variables. Oh, but this is actually this is a build. We actually have to go to the pod. The pod usually has the name. We don't want. Let's go to topology actually. And and go to patient DB without the ID, you know. The IDs are like for each instance of the pod and so on. So go to environment tab here. And you will notice that this is where you can add them through the web console. You can also add them through the command line. But this is also a nice way to see how it looks like on, you know, with the UI. So you can add from config map or secret. So this is what we will be using. Now we have to give it a very specific name because this is how it is specified in the code of that application. So make sure it is in caps lock, and then give it name cloudent underscore URL. You can find the name here. You can find it in step 7. Okay. And then go back, select a resource. So we created a secret, if you recall, and it's called cloudent binding. Okay, so we have to make sure that we select it from this list here and select a key. The key we'll be selecting is the URL. So this is the URL of the cloudent service that we just created. And then just make sure to save your changes and go back to your topology. The application should be running now. So yeah, I think it's running successfully. So next thing is we actually just finished with the back-end part, but we have to connect both the front end and back end together. And how we do that is just make sure you go to your front end application. So you can, however you're building your application, you can decide how you're going to connect your front end and back end. Maybe using it as an API or something. So this is just a demo, and it's showing you how you can, like how an example of using, for example, Node.js as backend. So for this one here, just make sure you're going to go to the step 5, exercise 5. And if you scroll below, you will see in step 3 in exercise 5, the route, which is patient DB 8080. So go back to the front end application and enter the backend URL here. You will see that it has shown us the also Java and Node, but make sure to select Node because the application is in Node.js. So now we will be able to log in to, you know, as users. You can use this name as username and password to log in and just sign in. There are different names. Is this the name I am using? Maybe it's a different one. I think there's this one here. I have to check again. Maybe I have to run it again. Start build. Let's give it a try to start the build. So as you can notice, when we fixed the issue of the environment variable of the PatientDB application, it was fixed. So it's currently running. So while it builds, let's go to our service. So this is what you get with, this is the view on IBM Cloud for the cloud service. Now we want to check the database because we run the application. So the application has a script with code, that has details about the patients in the database. So make sure you launch dashboard to be able to access the cloud database. Okay, a bit weird though. Yeah, it should work now. So this is the dashboard here, and it shows you the databases that you have. We have a different databases of allergies, appointments, and so on. So if you click on patients, you will be able to view the details of the patients. They are in JSON format. So you have the first name and the last name, and then you have the user ID and the password. So we can, for example, if you make changes to it, maybe you can give it a try and see how you can log in to the database if you make any changes. But you can use these credentials to log in to the application and, try to see how it's going to be connected to the database. And once you log in as each user, you will be able to view their information like appointments, allergies, and so on. So it might be a bit slow on my end. Sorry about that. But while this loads, hopefully it has loaded for you by now. We have so far, built. If you can take a look at the repository, we have built a front-end application, a back-end application, and we connected them together by using this link here, which is like the route to the back-end. And we used operators, OperatorHub to install the operator that we wanted. The operator that we use is IBM Cloud Operator to create a service and create a binding that are connected to our backend application so we can access it. So so you did not only learn OpenShift or operators, but you also learned one of the services on IBM Cloud. So hopefully you have, learned so many things with us in this, hands-on lab. Now, this might be taking such a long time to load, so I will just hand over to Fawaz. Hopefully, we'll be able to, run this application without having the same issue as myself. This is just probably coming from my side, maybe unlucky day. But yeah, Fawaz, would you like to take over?
Hello, I'm back. Hello, everyone.
Welcome back.
So, thank you so much, Masa, for such a nice hands-on session. Let me just share my screen. Yeah, I took my glasses off because I wanted to concentrate. So let me just go ahead. All right. So there we go. All right.
My application just worked. I'm going to just share the link.
You want to share? You want to share that?
No, I'm just sharing the link if anyone wants to use it to take a look at it.
Sounds good. All right. So thank you so much, Masa, for such an amazing workshop. It was really interesting. So let's go through a summary of what we went through today. First of all, OpenShift is built on top of operators. Okay, operators can be built with the help of Operator Framework SDK. Operators help ease the operational complexity. And as you saw, it was very easy for us to deploy an application, deploy a service on IBM Cloud using an operator itself, which was the IBM Cloud Operator. It was very easy for the administrator, which is Masa in our case, to actually install the operator using OperatorHub. And basically, it was installed on the whole cluster on specific projects. So some of the useful links, you can get your badge starting on the 13th at ibm.biz/BSOK skills. There's some links which we'd also like to keep here, which is the developer.ibm.com to try out different code patterns. There's Red Hat Developer. If you're interested in getting to know more about OpenShift, you can go to developers.redhat.com. And there's some e-learning on learn.openshift.com and cognitiveclass.ai. So build smart on Kubernetes. Once again, our next session will be on the 13th of July at 18 hours GST. It's going to be on continuous integration and deployment using Tekton pipelines. And I'm very excited for it, right? Before we go, I want to talk about Call for Code. Call for Code is our year-long initiative, which is towards humanitarian issues and basically using tech for good to fight issues towards climate change, and all of these things. Why would you join Call for Code? First of all, it's for skill building, for social good, for putting your ideas to actions, and moreover, you'll be joining a community of more than 400,000 developers coming in from 175 and 179 nations, and they've developed more than 15,000 applications. The awards for Call for Code, for the global winner, it's $200,000, and also support from the code and response team to make your to build your application towards a production scale. For the university challenge is $10,000, and for the Middle East and Africa challenge, it's $5,000. This year's themes are based on clean water and sanitation, zero hunger, responsible production, and green consumption. And there are some resources which we do have for you. We have some of the upcoming events. One of them went by on 5th of July, which was the final countdown as the submissions are coming in close. We do have some starter kits for you to get started based on these themes. And our next event is coming on the 12th of July. It's in around 2 to 3 days. So basically, it's all about the submission. We're really coming close to the submission, and we see some really amazing projects happening, right? You can also stay notified to for our upcoming events at meetup.com/IBM Cloud-MEA. And obviously, like I mentioned in the start, you can follow IBM Developer on Crowdcast to get notified about the upcoming events as well. Thank you so much for joining us today. My name is Fawaz Siddiqui, and with me I had Masa Abu Shamle. And let us know how we did. You can scan this barcode or push or go to the survey link and give your feedback, and that'll really help us. Thank you so much. Stay safe, keep your family safe, and have a great day or evening ahead.